Dear students, greeting to one and all. Today I am going to explain the estimation of total, permanent and temporary hardness present in the water sample. This is the water sample we have received from the outside. In the first year BTech, we are having the estimation of total hardness, temporary hardness, permanent hardness. So first I am going to explain how to do the estimation of total hardness. So we know that it is a complexometric titration. That is here the BRED solution is EDTA. It forms a complex with calcium and magnesium ions present in the water sample. Actually we are going to use the areochrome black tea indicator. First it forms a big complex with water sample. That is a big complex which is wine red in color when you add water sample to the areochrome black tea. Then it is titrated against with the EDTA taken into burette. So now the color will be changed from wine red to steel blue at the end point. This is due to the release of free indicator. But if you add buffer, then only you will be getting the correct end point, otherwise you will not be getting end point. So the buffer solution is very, very important. So if the buffer maintains the pH at 9 to 10, at this pH only, the calcium and magnesium ions forms a stable complex with EDTA. So now we can go on with the experiment. So first the burette is filled with EDTA solution. With the usual precautions. First you have to rinse the burette with distilled water before doing the procedure. So rinse the burette. Use the funnel. So using the funnel, by lifting the funnel we can do it like that, or we can keep the paper in between the funnel and burette. So first, before filling about the burette, first burette should be rinsed off with the EDTA solution. Wash the nozzle. Now I rinsed with the EDTA solution. The next fill the burette with EDTA solution. You have to lift the funnel carefully.
Parallel axis error.
So you have to follow the lower business. So now the burette is filled with EDTA solution. Then take the water sample. It's a clean conical flask one. So the water sample is first we have to rinse the pipette with water sample by taking the little quantity. So I am rinsing the pipette. So up to the bulb only you have to rinse it. So always that pipette should be well inside. It should be well immersed. So if you keep it like this, the solution may be going to mouth, going inside. Up to the bulb you have to pipette out. Then keep it in the eye level. You have to do it very slowly. Now I put it out 20 ml water sample into the clean conical flask. You have to drain the solution at last by touching the tip one like that, very gently. Don't do it vigorously. Don't blow the pipette. Then next, we have to add 5 ml of buffer solution. So what is the role of buffer? Buffer is added to maintain the pH 9 to 10. Five ml of buffer is enough. So at this pH only, the calcium and magnesium forms a stable complex with EDTA and releasing the indicator freely. If you do not add the buffer, it won't give the endpoint. Now to the 20 ml of water sample, now added 5 ml of buffer, then 2 drops of indicator is added. Now the color is wine red. This is due to the formation of weak complex, that is calcium and magnesium areochrome black tea complex. The calcium or magnesium ions forms the complex with areochrome black tea. This is the weak complex, which is wine red in color. Now I am going to titrate against with EDTA taken in the burette. So now what happens? The calcium magnesium ions EBT areochrome black tea complex reacts with the EDTA and forming calcium magnesium EDTA complex and releasing the indicator freely. So you have to add drop wise. Since the complex is formed, it is known as complexometric titration. So near the end point, somewhat violet color is appearing. So after that only you will be getting the steel blue. So near the end point, add drop by drop. Yes. So violet color, it will be slowly changing to steel blue. Yes. So near the end point, we will be getting somewhat violet color. So this is the intimation of the end point. Now, this is the color of the areochrome black tea. This is the color of the free indicator. So now the areochrome black tea is released and stable complex of calcium and magnesium EDTA complex will be formed. So now we are adding EDTA. It forms calcium magnesium EDTA complex. This is stable complex and releasing the areochrome black tea freely. The color of the areochrome black tea is only steel blue. complex color. This is the color of the area chrome black tea. You are getting the steel blue. It is the estimation of total harness. Now you have to note down the volume. So volume of EDTA is noted. Then repeat the titration once again to get the concordant value. So what is the concordant value? Concordant value means successive value should be same. For example, first I am getting 18.3 ml means once again you have to get 18.3. Then only it will be concordant value. Suppose if you get 18.4 means 18.3, it is not a concordant value. 18.3. The second value is 18.4. Third one is 18.3 means it is not concordant value. So once again you have to do it. Still you are getting the same successive values should be same. That's all. Then we can move to estimation of permanent harness. In permanent harness, take the same water sample. You have to fill the water sample. Now fill the water sample to 100 ml in a standard measuring flask. Then transfer this solution into the conical flask. Then you have to boil it for 15 to 20 minutes or the volume should be reduced to 1/3. So now what happens? On boiling, temporary harness will be removed. You can see the precipitate somewhat white color. It's maybe due to the decomposition of bicarbonates of calcium and magnesium. And decomposition of bicarbonates of calcium, it gives calcium carbonate, insoluble calcium carbonate. Then magnesium bicarbonate decomposes to form magnesium hydroxide. So you are getting that one. Precipitate. So now the temporary harness is removing. Now after boiling, now the volume is reduced to 1/3. You can see the precipitate. It is the precipitate of calcium carbonate and magnesium hydroxide. So now we have to allow for cooling for some time. Now I am filtering the decant liquid. The next, fold it. You have to take the filter paper, fold like this. Once again you have to make up the solution to 100 ml. Then you have to collect the washings. You have to transfer the solution through the glass rod only. So 3 times you have to wash it at least. Collect all the washings. So and remove the air gaps. You have to provide the air gap for the free flow of liquids. Once again you have to make it into 100 ml. So near the end point you can add drop by drop with the use of pipette. Just add 1 drop, that is 1 drop is required. You have to tilt it upside down like that. So put it in the left hand side palm and shake it well to get uniform mixing. So now we can estimate the permanent harness as usual. So before that, you have to fill up the burette once again at 0 level. Fill the burette up to 0 level. So once again rinse the pipette with boiled water sample. This is the boiled water sample. So rinse the pipette with boiled water sample. Now it contains only permanent harness because the bicarbonates of calcium and magnesium is removed. Now it contains chlorates and sulfates of calcium and magnesium. So repeat the procedure as like that of total harness. Same procedure we have to follow. So add 5 ml of buffer. Then add 2 drops of. Now you are getting the what is that? Wine red color. So permanent harness is present. Suppose if you do not get wine red color, then permanent harness is absent. So now the permanent harness is present. Now it is tightened against with EDTA taken in the burette. Since the total temporary harness is removed, the second value should be less than that of the previous one, total harness. Total harness means it put together permanent and temporary harness. It is only permanent harness, so the value should be less than total harness. Yes. So it is around, I think 5.7. So permanent harness is somewhat less. It's mainly due to bicarbonates. That is why you are getting more amount of precipitate. So now you are getting for permanent harness 5.7 ml. You have to repeat the titration to get concordant value. So you have to calculate total harness separately, then permanent harness separately by using the calculation, and difference will give the temporary harness. Thank you.